Voyager 1 is a breathtaking testament to human ingenuity and curiosity. Launched in 1977, this remarkably small spacecraft has traversed the vast reaches of the solar system and beyond, venturing where no human-made object has gone before, into interstellar space. As it now drifts deeper into the unknown, Voyager 1 continues to send back invaluable data about the cosmic environment beyond our sun's influence. Recent observations hint at phenomena that both challenge and confirm fundamental aspects of astrophysics, revealing mysteries that hold profound implications for our understanding of the universe. The birth of a star sailor. In the early 1970s, the Voyager program was conceived as a bold mission to explore the outer planets with unprecedented detail. The Voyager 1 spacecraft, roughly the size of a small car, was designed for durability and autonomy, equipped with a golden record, an interstellar message recording the diverse sounds and images of Earth. Directed by Dr. Ed Stone at NASA's Jet Propulsion Laboratory, the mission successfully navigated the grand tour of Jupiter, Saturn, Uranus and Neptune, leveraging gravity assist to extend its reach. Despite limitations in technology at the time, Voyager 1 continues to operate nearly 45 years after launch, a marvel of engineering resilience still beaming secrets from the edge of the solar system. The spacecraft's design prioritized robust systems capable of operating autonomously over decades, with minimal intervention due to the communication delay of over 18 hours at the edge of the solar system. The mission also carried groundbreaking scientific instruments designed to analyze planetary atmospheres, magnetic fields, and charged particles. Voyager 1's findings redefined our understanding of planetary formation and magnetic dynamo processes, revealing complex interactions within gas giants that challenged established physics. Most remarkably, the probe's longevity has surpassed initial expectations, continuing to provide valuable data well into the 21st century. The Grand Tour. Voyager 1's Grand Tour was a triumph of celestial navigation and scientific ambition. Utilizing precisely timed flybys, Voyager 1 collected invaluable data about the gas giants, revealing dynamic atmospheres, complex ring systems, and magnetic phenomena previously undreamt. Under the stewardship of Flight Director Suzanne Dodd and project scientists at JPL, the spacecraft gained speed from gravitational slingshots at Jupiter and Saturn, ultimately escaping the solar system's grasp. Visuals of Jupiter's storms and Saturn's rings reshaped planetary science, inspiring a generation and setting the stage for interstellar exploration. Each encounter enriched our knowledge, paving the way for humanity's journey into the galactic abyss. The success of the Grand Tour opened doors for extended missions including Voyager 2 and Pioneer 10 and 11, setting a new standard for deep space exploration. Data transmitted reshaped our comprehension of planetary weather, magnetic environments and ring systems, influencing models used in current astronomical research. Voyager 1's trajectory post-Saturn escape set the stage for humanity's first venture into interstellar space, marking a milestone achieved by no craft before. The meticulous planning and execution underpinning the mission exemplify the extraordinary human drive to explore beyond current horizons. The Golden Record. Embedded within Voyager 1 is the famous Golden Record, a time capsule crafted to communicate humanity's story to any extraterrestrial intelligence that might encounter it. Curated by a distinguished committee led by astronomer Carl Sagan, this 12-inch gold-plated copper disc includes greetings in 55 languages, music from diverse cultures around the world, and 116 encoded images depicting life on Earth. The record serves as a symbol of hope, friendship, and cosmic connection, acoustically traversing the vast gulf between stars as Voyager sails silently through the void. Its cover includes a pulsar map and scientific diagrams designed to communicate Earth's location in the galaxy to any intelligent beings who might find it. The selection process involved extensive deliberation about what aspects of human culture and knowledge would be most representative and comprehensible to alien minds. Beyond its scientific mission, the Golden Record transforms Voyager 1 into a cultural ambassador, carrying the essence of human civilization into the cosmos. This remarkable artifact represents humanity's first serious attempt at interstellar communication, embodying our deepest hopes for contact with other intelligent life forms in the universe. The record's contents reflect both our diversity and our common humanity, serving as a testament to Earth's rich cultural heritage. Years in the void. After completing its primary mission to the gas giants, Voyager 1 embarked on its extended journey through the outer solar system and beyond. For over 4 decades, this resilient spacecraft has continued to function in the harsh environment of deep space, enduring extreme cold, radiation bombardment, and the complete isolation of the cosmic void. Its instruments persistently measure solar wind particles, magnetic field strength, and cosmic ray intensity, delivering unprecedented insights into the heliosphere's structure and boundary. Despite operating far beyond its original design parameters, Voyager's radioisotope thermoelectric generators continue to provide sufficient power to maintain communication with Earth. The spacecraft's remarkable longevity has allowed scientists to study long-term variations in the solar system's outer regions and observe the gradual transition from solar-dominated to galactic-dominated space. Each data transmission, traveling over 14.5 billion miles to reach Earth, represents a triumph of human engineering and perseverance. Mission controllers have had to make increasingly difficult decisions about which instruments to keep active as power levels slowly decline. The probe's survival in this hostile environment has provided invaluable lessons for designing future deep space missions intended to explore even more distant destinations. Crossing the boundary. On August 25, 2012, Voyager 1 achieved a historic milestone by crossing the heliopause and entering interstellar space, becoming the first human-made object to leave the solar system. This momentous transition was marked by dramatic changes in the particle environment, a sharp increase in cosmic ray intensity, and a corresponding decrease in solar wind particles. Mission scientists led by Dr. Stamatios Krimigis carefully analyzed the data to confirm this unprecedented boundary crossing, which had been anticipated for years. The heliopause represents the edge of the heliosphere, the vast bubble of charged particles and magnetic fields created by our sun's solar wind. Beyond this boundary lies the interstellar medium, a realm filled with materials from other stars and the remnants of ancient stellar explosions. Voyager's instruments detected the sudden change in magnetic field orientation and particle composition that definitively proved it had entered this new domain. The crossing provided the first direct measurements of interstellar space, confirming theoretical predictions while also revealing unexpected complexities in the boundary region. This achievement marked the beginning of a new era in space exploration, as humanity finally had a probe operating in the galactic environment. The data collected during and after the crossing continues to reshape our understanding of how our solar system interacts with the surrounding galaxy. Signals from nowhere. In recent years, Voyager 1 has transmitted increasingly puzzling data that challenges our understanding of interstellar space. The spacecraft has detected mysterious plasma wave oscillations and unexpected magnetic field fluctuations that appear to have no obvious source or explanation. Dr. Larry Esposito and his research team have identified these anomalous signals as potential evidence of previously unknown interstellar phenomena or structural irregularities in the galactic medium. The signals from nowhere suggest that the space between stars is far more dynamic and complex than previously imagined, with rich physical processes occurring in regions once thought to be relatively empty. These mysterious transmissions have sparked intense scientific debate, with some researchers proposing they indicate interactions with dense interstellar clouds or magnetic field reconnection events. Others suggest the signals might represent encounters with the shock waves of distant stellar explosions that have propagated across the galaxy for millions of years. The data patterns don't match any known astrophysical models, forcing scientists to reconsider fundamental assumptions about the nature of interstellar space. Voyager's continuing journey deeper into this mysterious realm promises to reveal even more surprising discoveries about the hidden dynamics of our galactic neighborhood. The temperature mystery. One of the most perplexing anomalies discovered by Voyager 1 involves unexplained temperature fluctuations that defy conventional understanding of deep space thermal dynamics. Despite moving steadily away from the sun and into the cold depths of interstellar space, the spacecraft's sensors have recorded puzzling warming events that contradict expected cooling trends. Dr. John Napick leads the engineering team investigating these thermal anomalies, which could result from several possible mechanisms, including interactions with interstellar dust particles or energetic cosmic ray bombardment. The temperature variations might also indicate encounters with warmer regions of the interstellar medium or internal spacecraft issues affecting sensor calibration. These thermal mysteries have significant implications for mission longevity, as temperature extremes can impact the performance and lifespan of critical onboard systems. Understanding these fluctuations is crucial for predicting how long Voyager's instruments will continue functioning and for designing thermal protection systems for future interstellar missions. The spacecraft's ability to endure such extreme and variable thermal conditions far exceeds original engineering predictions, providing valuable insights into spacecraft survivability in the harsh interstellar environment. Resolving the temperature mystery remains one of the mission's most important ongoing challenges, as it affects both scientific interpretation and operational planning. Changing course. Maintaining Voyager 1's precise trajectory and communication alignment has required increasingly sophisticated navigation techniques as the spacecraft ventures deeper into interstellar space. Under the expert supervision of Flight Director Suzanne Dodd, mission controllers have executed subtle but critical thruster maneuvers to counteract natural orbital drift and maintain optimal antenna pointing toward Earth. These delicate course corrections ensure that Voyager's weak radio signals, transmitted with just 20 watts of power, continue to reach NASA's Deep Space Network receivers despite the enormous distance. The navigation team faces unprecedented challenges in predicting and correcting the spacecraft's path, as traditional gravitational models become less applicable in the interstellar environment. Recent trajectory adjustments have revealed unexpected external forces acting on the spacecraft, possibly related to pressure from interstellar gases or magnetic field interactions. The precision required for these maneuvers is extraordinary, considering that Voyager is now traveling at over 38,000 miles per hour relative to the Sun, and any navigation error compounds over vast distances. These course changes also provide valuable scientific data about the forces and conditions Voyager encounters in its interstellar journey. The ongoing navigation challenges demonstrate the remarkable dedication and expertise of the mission operations team in maintaining contact with humanity's most distant emissary. Ghost in the machine. Voyager 1's aging systems have begun exhibiting strange anomalies that mission engineers have dubbed the ghost in the machine. Unexplained glitches and data irregularities that seem to have no identifiable cause. The most prominent of these anomalies involves the spacecraft's attitude articulation and control system, which began sending garbled telemetry data that didn't match the probe's actual orientation and movement. Dr. Emma Woodfield leads the team investigating these mysterious system behaviors, which could result from cosmic ray damage, software degradation, or unexpected interactions between aging components. The anomalies became so severe that mission controllers temporarily lost the ability to determine Voyager's exact orientation in space, creating significant challenges for maintaining communication with Earth. After months of detective work, engineers managed to switch to a backup system and restore normal operations, but the incident highlighted the precarious nature of operating 46-year-old technology in the harsh interstellar environment. These ghost phenomena provide valuable insights into how spacecraft systems degrade over extreme timescales and help engineers design more robust systems for future long-duration missions. The successful resolution of these problems demonstrates the ingenuity and persistence of NASA's engineering teams in troubleshooting unprecedented technical challenges across interstellar distances. Patterns within patterns. Recent analysis of Voyager 1's scientific data has revealed intricate and unexpected patterns within the interstellar medium that suggest a far more complex and structured galactic environment than previously imagined. Dr. Harold Kruger directs ongoing research that has identified filamentary structures, spiral magnetic field configurations, and turbulent plasma waves swirling around the spacecraft's location. These patterns within patterns indicate sophisticated magnetic and energetic phenomena operating on multiple scales throughout interstellar space, from local turbulence to vast galactic structures. The observations suggest that the space between stars is not empty void but rather a dynamic, ever-changing medium filled with invisible currents and forces that shape the galactic environment. Voyager's measurements have detected evidence of shock waves from ancient stellar explosions, magnetic field boundaries between different regions of space, and complex interactions between interstellar gas and cosmic ray particles. These discoveries are revolutionizing our understanding of galactic physics and the processes that govern matter and energy flow throughout the Milky Way. The patterns Voyager observes may represent the fundamental architecture of our galaxy, revealing how stars, gas, and magnetic fields interact to create the large-scale structure we see in the cosmos. Each new data transmission adds another piece to this cosmic puzzle, gradually unveiling the hidden dynamics that govern our galactic home. Voyager 1's extraordinary journey continues to astonish scientists and space enthusiasts worldwide as it ventures deeper into the unknown reaches of interstellar space. The mysterious phenomena and unexpected discoveries it encounters challenge our fundamental understanding of the cosmos while revealing the incredible complexity of the galactic environment. What aspect of Voyager's journey fascinates you most? Share your thoughts in the comments below and subscribe to ʻOumuamua for more incredible stories of cosmic exploration and discovery. Until next time, keep looking up and wondering about the vast universe around us. When NASA's computers started receiving impossible data from the edge of our solar system, scientists couldn't believe what they were seeing. After 47 years of silent travel through the cosmic void, Voyager 1 has transmitted discoveries that challenge everything we thought we knew about interstellar space. Today, on ʻOumuamua, we're unveiling the shocking revelations that have left astronomers questioning the very nature of our universe. From mysterious humming sounds to unexplained cosmic phenomena, these findings will change how we view our place in the galaxy forever. The impossible mission that defied all odds. Voyager 1 was designed to last just 5 years, yet it's still transmitting data after nearly half a century, making it humanity's most successful space mission ever. In 1977, NASA launched what seemed like a routine planetary exploration mission. Voyager 1 and its twin, Voyager 2, were built using 1970s technology with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo today. Originally designed to study Jupiter and Saturn during a rare planetary alignment, these spacecraft were expected to go silent by 1982. Instead, they embarked on humanity's greatest journey into the unknown. The mission capitalized on a once-in-176-year gravitational alignment that allowed the spacecraft to use planetary gravity as cosmic slingshots, accelerating them toward the outer solar system. What began as a 5-year mission has become a 47-year odyssey that redefined our understanding of space. Today, Voyager 1 travels at 38,000 miles per hour through interstellar space, sending back data from regions no human-made object has ever explored. The fact that this 1970s technology continues functioning in the harsh environment of deep space represents one of engineering's greatest triumphs. Crossing the final frontier into interstellar space. On August 25, 2012, Voyager 1 became the first human-made object to leave our solar system, entering a realm where the sun's influence ends and true interstellar space begins. The moment Voyager 1 crossed the heliopause, the boundary between our solar system and interstellar space, marked a historic milestone for humanity. At 11 billion miles from the sun, the spacecraft detected a dramatic change in its environment. The solar wind, a stream of charged particles flowing from our star, suddenly dropped to nearly zero, while cosmic radiation increased threefold. This transition wasn't gradual, it was like stepping from a protected harbor into an open ocean. The heliopause acts as our solar system's shield, protecting us from the galaxy's intense radiation. Beyond this boundary lies the interstellar medium, a vast expanse filled with remnants from ancient star explosions, cosmic dust, and mysterious phenomena that scientists are only beginning to understand. Voyager 1's instruments detected strange magnetic field fluctuations and unexpected particle densities that contradicted existing models. The spacecraft found itself in an environment where the familiar rules of our solar system no longer applied. This crossing represented more than a technical achievement. It was humanity's first step into the galactic neighborhood, opening a new chapter in space exploration. The mysterious humming sound from the void. Voyager 1 detected a low, persistent humming sound in the supposed silence of interstellar space, a discovery that has scientists completely baffled about what's creating this cosmic symphony. In the vacuum of space, sound shouldn't exist. Yet Voyager 1's instruments detected something extraordinary, a continuous, low-frequency humming emanating from the interstellar medium itself. This wasn't sound as we understand it on Earth, but rather vibrations in the sparse gas and plasma that fills the space between stars. The humming appears to be generated by the interstellar medium's interaction with cosmic phenomena, creating a kind of cosmic background music that permeates our galaxy. Scientists describe it as similar to the sound of wind through trees, but occurring in a medium millions of times thinner than Earth's atmosphere. The discovery challenges our understanding of how energy propagates through space, and suggests that interstellar space is far more active than previously thought. These vibrations might be caused by stellar winds from distant stars, shock waves from supernovae, or even more exotic phenomena we haven't yet identified. The humming varies in intensity and frequency, suggesting it responds to changes in the local interstellar environment. This cosmic soundtrack provides scientists with a new way to study the structure and dynamics of our galaxy, turning Voyager 1 into an interstellar seismograph. The heliopause's shocking behavior. The boundary of our solar system isn't the stable barrier scientists expected. Instead, it's moving, shifting, and behaving in ways that completely contradict our models of how space works. The heliopause, which is our solar system's protective boundary, has revealed itself to be way more dynamic and unpredictable than anyone imagined. Rather than maintaining a steady position, this cosmic border actually fluctuates dramatically, sometimes moving billions of miles in relatively short periods. Data from Voyager 1 and 2 shows the heliopause exhibiting strange angles and irregular shapes that just defy current theoretical models. Back in 2014, NASA's Interstellar Boundary Explorer satellite detected unusual brightening of energetic particles, which suggested massive disturbances in the boundary region. These irregularities simply don't match existing predictions about how the solar wind should interact with interstellar space. The heliopause's movement might even explain why Voyager 1 and 2 reached interstellar space 6 years apart, even though they followed similar trajectories. Scientists have observed the boundary creating shock waves and turbulence that ripple through both the solar system and interstellar space. This dynamic behavior suggests our solar system is more like a living organism than a static structure, constantly responding to galactic forces we're only beginning to understand. The implications are pretty profound. If our solar system's boundary is this unstable, what does that mean for the protection it provides against cosmic radiation?
Electronic confusion in the cosmic deep.
So, in May 2023, Voyager 1 began transmitting garbled, incoherent data instead of scientific measurements, as if the spacecraft was suffering from electronic dementia in the depths of space. 46 years into its mission, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude articulation and control system started sending random, meaningless data instead of coherent status reports. From Earth's perspective, it honestly looked like Voyager 1 was losing its ability to communicate effectively, much like how a person with aphasia struggles to form coherent sentences. The mystery deepened when engineers realized that, despite the garbled communications, Voyager 1's radio signal remained strong and stable, which meant the spacecraft was still functioning normally. Its scientific instruments just kept operating without any awareness of the communication problem, and the fault protection system, designed to put the spacecraft in safe mode during emergencies, never activated. After a lot of investigation, NASA discovered the problem. The control system had switched to a computer that had been dormant for years, basically trying to use obsolete hardware to process modern commands. The solution required sending precise instructions across 15 billion miles of space to reactivate the correct computer system. This incident really highlighted the incredible challenge of maintaining 1970s technology in the harsh environment of interstellar space, where cosmic radiation constantly bombards the spacecraft's electronic systems. Surviving the impossible, technology beyond its limits. Voyager 1's instruments should have frozen solid years ago when NASA turned off their heaters to save power, yet they continue functioning perfectly in temperatures that would destroy any other spacecraft. Honestly, the laws of physics suggest Voyager 1 should have died long ago. As the spacecraft's plutonium power source gradually decays, NASA has had to shut down non-essential systems to conserve energy. In 2019, engineers made the tough decision to turn off the heaters that keep the scientific instruments warm in the -270 Fahrenheit environment of space. This should have been a death sentence for the delicate electronics, yet all 5 instruments continue operating flawlessly. NASA engineers are genuinely puzzled by this phenomenon, unable to explain how 1970s technology survives in conditions that would instantly destroy modern spacecraft. The instruments operate in temperatures hundreds of degrees below their design specifications, totally defying every engineering principle. Some scientists theorize that the instruments generate just enough internal heat from their electronic operations to prevent complete freezing, while others suggest that decades of cosmic radiation exposure may have altered the materials in unexpected ways. The spacecraft's resilience has actually forced engineers to reconsider fundamental assumptions about electronics in extreme environments. This unexpected durability has extended Voyager 1's mission far beyond anyone's wildest expectations, allowing it to keep transmitting data from the interstellar frontier where no human technology has ever ventured.
The cosmic radiation bombardment.
Beyond our solar system's protective shield, Voyager 1 faces a constant barrage of cosmic radiation that's, wow, 3 times more intense than anything experienced within our cosmic neighborhood. Interstellar space has revealed itself to be a far more hostile environment than scientists ever anticipated. Once Voyager 1 crossed the heliopause, it encountered cosmic radiation levels 3 times higher than those within our solar system's protective bubble. This intense radiation, consists of high-energy particles accelerated by distant supernova, black holes, and other extreme cosmic phenomena. These particles constantly bombard the spacecraft, gradually degrading its electronic systems and creating cumulative damage that just builds over time. The radiation can actually flip individual bits in computer memory, causing small errors that accumulate into much larger problems. It's honestly like trying to maintain a complex machine while it's being continuously sandblasted by invisible particles traveling at nearly the speed of light. Despite this constant assault, Voyager 1 systems continue functioning through a combination of robust 1970s engineering and clever software workarounds developed by NASA's engineers. The spacecraft's experience provides crucial data about the radiation environment that future interstellar missions will face. Understanding these conditions is essential for designing spacecraft capable of surviving the journey to nearby star systems. Voyager 1 has become humanity's first radiation scout, mapping the dangerous terrain that lies between the stars and providing invaluable information for future deep space exploration.
Software updates across the cosmic void.
NASA engineers regularly send software updates to Voyager 1 across 15 billion miles of space, basically providing tech support to a computer system that's actually older than most of the engineers working on it. Maintaining Voyager 1 requires honestly some of the most challenging technical support in human history. The spacecraft operates with 1970s computer systems programmed in assembly language, a low-level programming code that directly controls hardware components. When problems pop up, NASA engineers have to write new software instructions and transmit them across the vast emptiness of space, where radio signals take over 22 hours just to reach the spacecraft. The engineers use a mix of assembly language and pseudocode to create efficient programs that won't overwhelm the spacecraft's limited 70-kilobyte memory. Each software update has to be perfect. There's really no chance for quick fixes or patches when your target computer is billions of miles away. These updates have solved critical problems throughout the mission, from reactivating backup systems to working around failing components. In one case, a software update saved Voyager 1 from potential disaster by activating fail-safe mechanisms when a hardware component failed. The process requires engineers to think like programmers from the 1970s, using techniques and limitations that modern computer scientists rarely ever encounter. This cosmic tech support is, honestly, one of the most impressive examples of long-distance troubleshooting ever attempted, keeping humanity's most distant ambassador operational out in the depths of interstellar space.
Revolutionary discoveries that changed everything.
Voyager 1's journey revealed that Jupiter has 3 delicate rings, Saturn's rings contain thousands of intricate braids, and volcanoes exist on moons we once thought were totally dead, completely revolutionizing our understanding of the outer solar system. Before Voyager 1's grand tour, our knowledge of the outer planets was limited to fuzzy telescope images and just basic orbital mechanics. The spacecraft's close encounters showed us a solar system far more complex and dynamic than anyone had imagined. Jupiter, which we thought was a calm gas giant, turned out to be a world of extremes, with hundreds of violent storms, glowing auroras, and 3 previously unknown rings that are honestly more intricate than fine jewelry. Saturn's rings, once considered simple and few in number, revealed themselves as thousands of individual ringlets with braided structures that seemed to defy the laws of physics. Most shocking of all was the discovery of active volcanoes on Jupiter's moon Io and nitrogen geysers on Neptune's moon Triton, erupting at temperatures just 40 degrees above absolute zero. These findings totally shattered the idea that volcanic activity was unique to Earth and the inner planets. Maybe most significantly, Voyager 1 identified potential habitats for life on Europa and Enceladus, moons harboring vast liquid oceans beneath their icy surfaces. These discoveries transformed our understanding of where life might exist in the universe, expanding the concept of habitable zones way beyond traditional planetary boundaries. The mission's revelations keep influencing space exploration today, inspiring missions to study these potentially life-bearing worlds in much greater detail.
The eternal journey into galactic immortality.
In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, carrying humanity's golden record message to any intelligent civilization that might find it. Voyager 1's scientific mission may end in the late 2020s when its power finally fails. But honestly, its journey through the galaxy is just beginning. The spacecraft will keep traveling through interstellar space for millions of years, eventually becoming an artifact of human civilization drifting among the stars. In about 300 years, it'll enter the Oort cloud, a spherical shell of comets surrounding our solar system. After 30,000 more years, it'll completely escape the sun's gravitational influence and start orbiting the center of the Milky Way galaxy alongside billions of stars. The golden record attached to Voyager 1 contains sounds, images, and greetings from Earth in 55 languages, serving as a cosmic message in a bottle for any intelligent beings who might encounter it. This record includes everything from Bach's music to whale songs, from mathematical formulas to images of human faces. The spacecraft has become humanity's first interstellar ambassador, carrying our story into the cosmic deep. Long after human civilization has evolved beyond recognition, Voyager 1 will continue its silent journey through the galaxy, a testament to human curiosity and our drive to explore the unknown. The mission represents more than scientific achievement. It really embodies humanity's eternal quest to understand our place in the universe and reach beyond the boundaries of our cosmic home. From mysterious cosmic humming to impossible electronic survival, Voyager 1's 47-year journey has shown that our universe is far stranger and more dynamic than we ever imagined. This brave little spacecraft keeps rewriting the textbooks of space science while carrying humanity's message to the stars. If you're fascinated by these incredible cosmic discoveries and want to explore more mind-bending space mysteries, go ahead and hit that like button, share your thoughts about Voyager's amazing journey in the comments, and subscribe to Sci and Y for more adventures into the unknown. Thanks for watching. Keep exploring the cosmos. NASA's James Webb Space Telescope has achieved a groundbreaking feat by capturing the first real image of the enigmatic interstellar object, 3Y Atlas. This remarkable milestone opens a new chapter in our understanding of cosmic wanderers and the mysteries they hold. The data reveals unprecedented details that challenge previous notions about interstellar visitors. Join us as we unravel the story behind the flicker in the telescope's data leading to this profound discovery, the object's incredible speed from the void, and the secrets it may unlock about our universe. The flicker in the data. In late 2025, astronomers noticed a faint flicker within vast datasets collected by advanced telescopes across multiple observatories worldwide. Initially dismissed as background noise or instrumental error, this subtle signal sparked curiosity among researchers at NASA when artificial intelligence algorithms began flagging anomalous patterns. Analysts utilized cutting-edge machine learning algorithms to isolate these anomalous data points corresponding to an object moving at extraordinary speed through our galaxy. Subsequent observations confirmed the flicker as 3Y Atlas, a massive interstellar visitor entering our solar system from the depths of space. This serendipitous detection was a testament to the increasingly sophisticated analytical methods enabling the discovery of elusive cosmic travelers from the vast interstellar void. The discovery process highlighted how modern astronomy relies on both advanced technology and human intuition to identify phenomena that would have been completely invisible to previous generations of scientists. The flicker represented humanity's first glimpse of what would become the most significant interstellar discovery since ʻOumuamua. offering unprecedented insights into phenomena previously beyond our reach and understanding. 152,000 miles per hour from the void. 3Y Atlas barrels through space at a staggering velocity of approximately 152,000 miles per hour, or about 68 kilometers per second, defying all known celestial norms and expectations for objects in our cosmic neighborhood. This extraordinary speed has been confirmed through precise orbital tracking conducted by teams at NASA's Jet Propulsion Laboratory, utilizing multiple ground-based and space-based observation platforms. The velocity calculations show this speed dwarfs any traditional simulation of interstellar objects passing through our solar system, suggesting origins from an incredibly distant star system. Such immense velocity indicates the object has traversed the vast interstellar void for potentially millions of years, subjected to cosmic radiation bombardment and gravitational perturbations from countless stellar encounters. Its trajectory through the ecliptic plane positions it for brief but critical visibility windows, prompting astronomers worldwide to mobilize for intensive observation campaigns using every available telescope and sensor array. Understanding this rapid journey through space enhances our fundamental grasp of galactic dynamics and the frequency of alien visitors crossing our cosmic neighborhood, while raising profound questions about the forces that could accelerate such massive objects to these incredible speeds. 3 visitors, 7 years. Since the epical discovery of Oumuamua in 2017, followed by the comet-like 2I Borisov in 2019, humanity has witnessed 3 confirmed interstellar intruders within a span of just 8 years. This unprecedented sequence has fundamentally transformed our perception of the solar system's place within the broader galactic environment and the frequency of cosmic visitors. Each visitor displays unique physical and dynamic attributes, painting an increasingly complex picture of materials ejected from diverse planetary systems across the galaxy. The arrival of 3I Atlas, significantly larger and faster than its predecessors, magnifies the urgency in understanding the true diversity and origin of such objects in our cosmic neighborhood. As observational technology advances and detection methods become more sophisticated, the frequency of such encounters may reveal long-hidden cosmic realities about interstellar traffic patterns. The pattern suggests that interstellar visitors may be far more common than previously imagined, fundamentally challenging our understanding of solar system dynamics and the movement of matter between star systems. These discoveries collectively indicate that our solar system exists within a much more active and dynamic galactic environment than scientists previously recognized, with implications for planetary formation, asteroid populations, and the potential for life-bearing materials to travel between worlds. James Webb's metallic discovery. So James Webb's metallic discovery, well, the James Webb Space Telescope's recent high-resolution imaging of 3I/Atlas, has delivered completely unexpected revelations about its surface properties and composition, and honestly, these findings have just stunned the scientific community. Comprehensive spectral analysis, which was conducted by Dr. Liam Cheng and his international research team, detected a predominantly metallic composition. This fundamentally challenges those long-held assumptions that interstellar objects are mostly icy or rocky bodies. Now, this distinctive metallic signature, it suggests either advanced natural processing through some truly extreme cosmic conditions, or, potentially, artificial construction by unknown technological means. Reflected light patterns captured by Webb's advanced infrared instruments indicate an unusually smooth, potentially engineered surface, instead of the rough, pitted texture that's typical of natural asteroids or comets. The metallic composition even appears to include elements not commonly found in typical solar system objects, like rare earth metals and isotopes that suggest formation under, well, exotic stellar conditions. These groundbreaking findings open the door to revolutionary hypotheses regarding non-natural origins, and they're really compelling scientists worldwide to expand their investigative methodologies and fundamentally reconsider their definitions of cosmic phenomena. The discovery has prompted emergency funding for additional observation time, and it's sparked some intense international collaboration to analyze every detail of this unprecedented visitor before it disappears forever into the depths of space. The machine that steers itself. This is honestly one of the most astonishing and scientifically challenging aspects of 3I/Atlas. It's the object's apparent ability to modify its trajectory mid-course. which strongly implies the presence of an intrinsic navigation or guidance system. Groundbreaking research led by aerospace engineer Dr. Sofia Martinez has documented subtle but measurable variations in velocity and orientation that just remain completely inconsistent with gravitational influences alone. These adaptive steering capabilities suggest highly sophisticated onboard systems, either responding intelligently to external stimuli or fulfilling some form of pre-programmed interstellar mission. This phenomenon, well, it raises some profound and honestly unsettling questions about whether such objects represent autonomous probes, rather than just mere geological debris drifting through space. The trajectory adjustments seem to occur at specific intervals and follow patterns that suggest deliberate course corrections, probably designed to optimize the object's path through our solar system. Such capabilities would require technology far beyond anything currently possessed by human civilization, involving either advanced artificial intelligence or direct control by some form of intelligence. The implications here challenge existing space exploration frameworks, and they invite some pretty serious speculation about extraterrestrial engineering and the possibility that 3I/Atlas represents humanity's first encounter with genuine alien technology actively operating within our solar system. Information blackout. Despite intense scientific scrutiny from observatories worldwide, much crucial information about 3I/Atlas still remains, well, mysteriously enigmatic due to unprecedented government-imposed data restrictions and communication blackouts. Classified satellite data and systematic communications jamming really hint at a broader, coordinated information suppression campaign designed to deliberately suppress sensitive knowledge regarding the object's true nature and potential origins. Whistleblowers, including former intelligence officer Dr. Eleanor Hayes, suggest that agencies across multiple governments participate in coordinated secrecy operations that span international boundaries. This systematic information blackout has fueled widespread conspiracy theories and public frustration, while at the same time underscoring the immense challenges legitimate scientists face in accessing comprehensive datasets needed for proper analysis. The restrictions appear to target specific wavelengths of electromagnetic observation and particular types of gravitational measurements, which suggests authorities know exactly what they want to conceal from public knowledge. Transparency advocates and scientific organizations worldwide argue vigorously for immediate declassification to advance scientific understanding and, properly prepare humanity for potential first contact scenarios. The secrecy has created an unprecedented divide between official government statements and the growing body of leaked evidence, suggesting 3I/Atlas represents something far more significant than a simple interstellar asteroid. Adaptive shielding technology. So, recent theoretical models developed by leading physicists propose that 3I/Atlas employs this, highly advanced adaptive shielding technology. It's apparently capable of rendering it nearly invisible to conventional detection methods, and that's across multiple electromagnetic spectra. The Max Planck Institute, they've elaborated on these sophisticated hypotheses involving electromagnetic cloaking fields and dynamic surface morphing, which could help explain the object's, mysteriously elusive signatures. Such revolutionary shielding technology would, at least in theory, allow the object to systematically evade host planetary defense systems and observational arrays, basically making completely discrete movement through solar systems possible. The proposed technology involves real-time manipulation of electromagnetic properties, possibly through programmable metamaterials that can alter their reflective and absorptive characteristics instantaneously. Investigations into these extraordinary properties may, honestly, revolutionize human understanding of stealth technology, with some pretty profound implications for both planetary defense systems and future space exploration capabilities. The adaptive shielding seems to actually respond to different types of observation attempts, becoming more transparent to certain wavelengths while staying opaque to others, in patterns that, suggest intelligent control. If confirmed, this technology would represent a quantum leap in material science and electromagnetic manipulation, far beyond anything achievable with current human knowledge, and could potentially provide blueprints for revolutionary advances in spacecraft design and planetary protection systems. The Ancient Probe Network. So, emerging evidence increasingly suggests that 3I/Atlas might represent a crucial component of a vast ancient probe network, potentially constituting a galactic surveillance system initiated by an advanced civilization that predates human existence by millions of years. Leading astrobiologist Dr. Maya Singh describes how such interconnected probes could, in theory, monitor planetary systems across thousands of light-years, relaying comprehensive information through quantum entanglement communication systems or, even faster-than-light transmission methods. These sophisticated networks might encode prime number sequences within their thermal signatures, functioning as distinguishing identification markers or complex mathematical messages designed for detection by emerging technological civilizations. The probe network theory, honestly, suggests a level of galactic organization and long-term planning that completely transcends human technological capabilities and temporal perspectives. Each probe would operate semi-autonomously while maintaining connection to a larger intelligence network, gathering data on planetary development, biological evolution, and technological advancement across, countless worlds. Such a discovery would fundamentally redefine humanity's place in the cosmos, indicating we exist within a much larger, interconnected interstellar intelligence system that has been operating for eons. The implications extend really beyond mere scientific curiosity, suggesting that human development may have been observed and possibly influenced by these ancient sentinels, heralding a new era in astronomical, philosophical, and existential understanding of our role in the universe.
Prime numbers in heat signatures.
Scientists analyzing the thermal emissions from 3I/Atlas have detected increasingly intriguing patterns featuring prime number sequences, which, many researchers interpret as deliberate mathematical signals rather than just random electromagnetic noise. A renowned mathematician emphasizes that these precise numerological features could represent a sophisticated, intelligent encoding method, strongly indicating deliberate communicative intent from the object. These remarkable findings add substantial credence to the hypothesis that 3I/Atlas represents an artificial probe, and they've sparked unprecedented new interdisciplinary studies combining advanced astrophysics with information theory and cryptographic analysis. The presence of prime number sequences in electromagnetic emissions is widely considered among scientists as, honestly, potentially universal evidence of technological civilization, effectively bridging the gap between purely cosmic phenomena and potential extraterrestrial intelligence communications. The patterns appear in multiple frequency ranges and follow mathematical progressions that would be, virtually impossible to produce through natural processes alone. The sequences begin with simple primes like 2, 3, 5, and 7, then progress to increasingly complex mathematical relationships that suggest a deliberately constructed communication protocol. International teams of mathematicians and physicists are working around the clock to decode additional layers of meaning embedded within these thermal signatures, while astronomers continue monitoring for any changes in the transmission patterns that might indicate active communication attempts or responses to human observation efforts.
We were never the observers.
The revolutionary notion that humanity has never been the sole observers of the cosmos is, honestly, gaining unprecedented traction through intensive study of 3I/Atlas and its profound implications for our understanding of galactic civilization. Ongoing research strongly suggests that Earth has been an integral part of a carefully monitored network within a complex universe where multiple advanced civilizations may observe and interact discreetly across vast interstellar distances. A philosopher promotes the groundbreaking idea that 3I/Atlas may represent a sophisticated sentinel, serving as a stark reminder that our species has been under systematic scrutiny by significantly more advanced intelligences throughout our evolutionary development. This paradigm-shifting revelation fundamentally challenges deeply ingrained anthropocentric worldviews and invites, profound reflection on the true nature of consciousness, intelligence, and existence within a potentially vast, collaborative galactic community. The evidence suggests that what we interpreted as humanity's journey of discovery and exploration has actually been occurring under the watchful eyes of ancient observers who have been cataloging our progress for millennia. This realization transforms our entire perspective on human achievement, technological development, and our future role in what appears to be a much more interconnected and sophisticated cosmic civilization than we ever dared imagine, fundamentally altering our approach to space exploration, scientific research, and our search for extraterrestrial intelligence. James Webb's capture of 3I/Atlas's first real image marks a historic milestone in humanity's encounter with the cosmos and our understanding of our place within it. The implications resonate across science, philosophy, and society, hinting that we may be standing on the threshold of profound discovery and possible first contact with extraterrestrial intelligence. What are your thoughts on these revelations? Share your perspectives in the comments. Subscribe to CI and Y for more cosmic insights and continue looking upward to the stars where ancient mysteries await our discovery. For all of human history, the moon has been our silent, constant companion in the night sky. We've seen it as a deity, a destination, and, well, a dead world. But recent events have shattered that last perception. A groundbreaking discovery by China's space program has confirmed that our moon is not a static relic, but a dynamic body teeming with resources that could, honestly, redefine humanity's future, turning science fiction into scientific fact. So, what did they find, and how does it connect to the decades of mystery surrounding our moon? Let's dive in. Anomalous lunar structures. The conversation about inexplicable objects on the moon often circles back to a single pivotal mission, the 1994 Clementine mission. This was not a standard NASA science mission, it was a joint project with the United States Department of Defense's Ballistic Missile Defense Organization. Its official purpose was testing advanced lightweight sensors by mapping the moon, but its military oversight has, fueled speculation that its agenda was more than purely scientific. From the massive trove of 1.8 million digital images it sent back, a few select frames have become legendary within circles that investigate lunar anomalies. These images, especially from the perpetually hidden far side of the moon, appear to contain features that defy easy geological explanation. There are patterns that look unnervingly geometric, with straight lines and sharp 90-degree angles that some interpret as the weathered ruins of immense ancient structures. The most famous of these is a feature that strikingly resembles a massive three-sided pyramid. While the scientific consensus attributes these oddities to a combination of digital image compression artifacts and the deceptive play of light and shadow across an alien landscape, many researchers remain unconvinced. They point to what they see as signs of deliberate censorship, like patches of unnatural blurring or obfuscation, suggesting that the Clementine mission was, in fact, a reconnaissance flight to get a closer look at something that was already known to be there. Ancient astronaut connections. The intriguing possibility of lunar ruins feeds directly into the wider, captivating theory of ancient astronauts. This hypothesis suggests that intelligent extraterrestrial species have been visiting Earth for millennia, and that their influence is recorded in our oldest myths, artworks, and sacred texts. This lens reinterprets our history not as a story of primitive superstition, but of misunderstood technology. For instance, a persistent piece of UFO folklore is a supposed secret transcript from the Apollo 11 mission, where Neil Armstrong allegedly expressed shock at seeing massive alien craft and structures. A story that has been thoroughly debunked by NASA but, continues to circulate. This narrative is woven into reinterpretations of ancient texts, such as the Sumerian cuneiform tablets. In one tale, a godlike being from the Anunnaki advises his son, before a journey to the moon, to wear his eagle's mask. Proponents of the theory argue this is a clear description of a helmet, a piece of life support technology. This same re-examination is applied to ancient art across the globe, most notably the Wandjina cave paintings in Australia. These ancient artworks depict beings with large dark eyes and heads surrounded by a halo-like ring, which look remarkably similar to a modern astronaut viewed through the visor of their helmet. The question the theory poses is a powerful one. Were our ancestors painting gods, or were they painting visitors? China's groundbreaking discovery. Moving from compelling theories to verifiable facts, China's space program has recently delivered hard, verifiable evidence that is, in its own way, just as revolutionary. The nation's Chang'e 5 mission was a masterpiece of robotic engineering. In December 2020, it successfully touched down in a previously unexplored region of the moon, drilled into the regolith to collect samples from beneath the surface, and then returned 1,731 grams of lunar material to Earth. It was the first time in 44 years that humanity had brought back a piece of the moon. After more than a year of intense analysis, Chinese scientists made two monumental announcements in 2022. The first was the identification of a completely new mineral, a phosphate crystal they named Change Site Y. This placed China in an exclusive club with the United States and the former Soviet Union as one of only 3 nations to have discovered a new lunar mineral. The second discovery, however, had even more profound implications. They found definitive proof of water, not as ice, but as molecules trapped inside tiny beads of glassy material forged in the heat of ancient asteroid impacts. This finding completely changed the scientific understanding of lunar water, proving it wasn't just isolated at the frigid poles but was, in fact, distributed far more widely across the moon's surface. Revolutionary implications. So, this confirmation of widespread water on the moon is honestly a watershed moment for the future of human space exploration, because it really validates the concept of in situ resource utilization, or ISRU. That's the principle of using local materials to create what you need to survive, instead of hauling everything from Earth. For decades, the dream of a permanent lunar base just seemed totally out of reach, mostly because of the massive costs involved in launching all the water, oxygen and fuel required. But China's discovery, well, it completely reshapes that calculation. Even though each glass bead contains only a tiny amount of water, the sheer volume of lunar soil means there could be as much as 270 billion metric tons of water up there. Future missions could send rovers to heat the soil, releasing the trapped water as vapor, which could then be collected and condensed. This water would be absolutely vital for drinking and for irrigating crops in lunar greenhouses. And perhaps even more importantly, electricity can split the water into its base components: breathable oxygen for life support, and powerful hydrogen for rocket fuel. This really transforms the moon from just a desolate stopover into a self-sufficient exploration hub, and honestly, a fully functional gas station for missions heading deeper into our solar system. The Chang'e program evolution. China's lunar triumphs aren't just the result of a single lucky mission. They're actually the culmination of a patient, multi-decade, and brilliantly executed strategy called the Chinese Lunar Exploration Program, or CLEP. This program was designed as a deliberate 3-step progression, each step more complex than the last. The first step was becoming a lunar satellite state, pulled off with the Chang'e 1 and Chang'e 2 orbiters. These missions created high-resolution maps of the entire lunar surface and identified potential landing sites for the future. The second step was achieving a surface landing, and that milestone was reached in 2013 with the Chang'e 3 mission, which deployed the U2 rover, a major national achievement. Then China showed off its advanced capabilities with the historic Chang'e 4 mission in 2019, pulling off a world first by successfully landing on the far side of the moon. That took a dedicated relay satellite to solve the communication blackout problem. The third step, which was the most complex, was sample return. The Chang'e 5 mission nailed this in 2020, performing a landing collection, a launch from the moon, a robotic rendezvous in lunar orbit, and a safe return to Earth. This methodical step-by-step approach has really shown without a doubt that China has arrived as a top-tier space power. Resource revolution on the moon. The samples returned by Chang'e 5 have, honestly, unleashed a scientific revolution. They've recast our view of the moon, so it's not just a geological artifact anymore. It's a vast repository of strategic and economic resources. The discovery of the new mineral, Changesite Y, is more than just a novelty. It's significant because it's a phosphate mineral containing helium-3, which is extremely rare on Earth, but has been sprayed onto the moon's surface by the solar wind for eons, getting trapped in the top layer of regolith. A lot of physicists consider helium-3 to be the ideal fuel for nuclear fusion, which is like the holy grail of energy production. Fusion reactors powered by helium-3 could generate huge amounts of clean energy, with no greenhouse gas emissions and none of the dangerous long-lasting radioactive waste you get from today's nuclear fission plants. The ability to mine helium-3 on the moon could, one day, actually secure humanity's energy future. Beyond that, lunar soil is also rich in rare earth elements, which are vital for making everything from smartphones and electric cars to advanced defense systems. So, the moon could become a critical source for these materials, helping to ease the environmental damage and geopolitical tensions that come with mining them here on Earth. Future lunar colonization. With the confirmation of accessible water, a potential source of near-limitless energy from helium-3, and abundant construction materials, the vision of a permanent human settlement on the moon has leaped from the pages of science fiction into the formal strategic planning of major world powers. This vision took a significant step toward reality in March 2021, when China and Russia officially announced a joint partnership to build the International Lunar Research Station, or ILRS. This is a profoundly ambitious project to establish a permanent and eventually fully autonomous scientific outpost near the Moon's south pole. This location is highly strategic due to the presence of large quantities of water ice believed to be trapped in its permanently shadowed craters. The ILRS is designed to be a hub for scientific discovery, technology verification, and large-scale resource extraction. It will serve as the crucial proving ground for the systems and technologies necessary to sustain human life for long durations in the harsh environment of deep space. And underscoring the seriousness of this commitment, Chinese space officials have stated their intention to have a nuclear power plant operational on the Moon by 2028 to power the station's construction and early operations. Lunar resources, the new gold rush. The definitive discovery of vast and valuable resources on the Moon has officially ignited a 21st century gold rush. This has created an intense geopolitical competition to claim and control the most strategic locations, turning the lunar South Pole into the most sought-after real estate in the solar system. This land rush, however, is taking place in a dangerous legal vacuum. The foundational treaty of space law, the 1967 Outer Space Treaty, is clear on one point. It explicitly prohibits any nation from making a claim of sovereignty over the Moon or any other celestial body. No one can own lunar land. However, the treaty is critically vague on the issue of resource exploitation. It does not provide a clear legal framework for whether a nation or a private company can mine lunar resources and claim ownership of them. This ambiguity has created a high-stakes race where the prevailing logic is that possession is 9/10 of the law. Nations are now rushing to establish a physical presence, to land rovers, build habitats, and demonstrate resource extraction, in the belief that these actions will establish a de facto precedent, strengthening their position in future negotiations over who gets to write the rules for the lunar economy. International space race. Today's race back to the Moon is a fundamentally different beast from the two-horse race of the Cold War. It is a global, multipolar, and heavily commercialized affair. One of the principal efforts is led by the United States through NASA's Artemis program. The goals of Artemis are not just to repeat the achievements of Apollo, but to go further by establishing a sustainable, long-term human presence on the Moon, with a landmark commitment to landing the first woman and the first person of color on the lunar surface. The defining characteristic of the American approach is its deep and unprecedented partnership with the private sector. Instead of developing all of its own hardware in-house, NASA has embraced a commercial model awarding multi-billion-dollar contracts to companies like SpaceX and Blue Origin to build the landing systems that will carry its astronauts. This collaborative philosophy is legally enshrined in the Artemis Accords, a US-led international agreement that sets forth principles for peaceful and transparent cooperation in space. With dozens of signatory nations, it forms a broad coalition built on a shared vision, standing in contrast to the more state-centric models of its global competitors. Competition between China, US, and other nations. The geopolitical chessboard of this new space race is rapidly organizing into two primary alliances. In one corner there is the US-led coalition of nations that have signed the Artemis Accords, which includes established space powers like Japan, Canada, and the member states of the European Space Agency. In the other corner is the burgeoning partnership between China and Russia, centered on their ambitious plans for a joint international lunar research station, which is steadily attracting its own international partners. However, this is not a simple bipolar conflict. Other nations are carving out their own paths and emerging as significant independent forces. In a spectacular display of technical skill, India's Chandrayaan-3 mission made history in 2023 by becoming the first nation ever to achieve a soft landing near the lunar South Pole. This historic achievement instantly established India as a major player and a critical contender in the search for lunar water ice. The current landscape is a complex and dynamic interplay of national ambition, commercial interests, and strategic alliances. While intense competition is currently driving innovation at a breathtaking pace, the sheer crushing difficulty and expense of operating on the Moon may ultimately force these rivals into a new era of global cooperation. The moon is no longer just a beautiful light in our sky, it's a destination, a resource depot, and a critical stepping stone to the rest of the cosmos. China's discoveries have opened a new chapter in human exploration, one that will challenge us technologically and force us to decide how we will explore these new frontiers together. What do you believe is the most important resource the moon has to offer? Share your thoughts in the comments. Don't forget to like, subscribe, and hit the bell icon for more explorations into the science and wonder of our universe. Thanks for watching Sci and Why.